your presentation, and the time is yours.
Thank you very much, Sensei Binur. The long time not see you, and I'm very glad to see you again. Okay, okay. Thank you very much. Today, I will present my work about application of the pre-circuit heat exchanger for small modular molten salt reactor. And previous Dr. Binur already introduced about me, and my name is Bambang Joko Suroto, and now assistant professor in the Motion Technology Department on Teknologi Daya Gerak, Faculty of Defense Technology, University of Indonesian University of Defense. Okay, this is my abstract, and we know well that everything needs energy. In the military operation, there are three things that must be paid the big concern: fuel, water, and food. And without energy, the army is already died. Okay, so we must answer the dynamical problem. Mr. Colonel Yarib already present about how the energy security dynamic politic is affected on the price of the energy. So we must find the smart to answer the what next the energy for our military in the operation and the peace situation. Okay, in this case, I try to talk about the molten salt reactor, because this is the one the promising nuclear reactor in the future for the some reason. Okay, background and current issue. Okay, fuel consumed by TNE. As because I don't have the exact data from the TNE, and because I don't have access to explore the data, I get the data from the KT data and Merdeka.com that the every year TNE consume the huge fuel, and this supplied by single supplier. They are state-owned oil company, Pertamina. And when in the convert to the money, TNI must spend about 6.2.7 trillion Indonesian dollar. It's the very huge money, okay? And second one, uh, we know well from the elementary school that our country is consists of many thousand islands, and the first 70% of our territory is the sea. And when President Jokowi declared that BBM satu harga, the effect from the policy is very complexity, and the education is also face same situation as in the TNE. You know that energy is backbone of defense and essential for the effectiveness of operation. The archipelago state like Indonesia has specific characteristic when the deploy the army spread it over in the country. We have the deep complexity in energy distribution and security. You can imagine whether any invasion to our country, and when deliver fuel from another island to other island. For example, Kostrat in Sorong, Pasmar in Sorong, there are any bridges. How many thousand army on there? And need the fuel to support their operation. How to profit the fuel? I think it's big problem. And the and so when they deliver fuel by ship or by airplane, this time consume, costly, and also risk, very risk. When we send the fuel by ship, you need quad warship. It is also consume the fuel for the running the quad escort in the navy. Okay, the absence of the option for other fuel scheme. I think Mr. Benny is very interesting to fulfill the problem. Okay, to solve the problem by renewable energy. So the consequence from the previous explanation that fragile in endurance and robustness to support military operation of an invasion from adversary of the country. We must solve the problem. Okay. No. Okay. It is example. U.S. military figures show the resupply of liquid fuel and drinking water to troops in the theater costs about 4 lives for every 100 convoy. It makes an army more vulnerable and limit movement. The U.S. Army has a big problem when they resupply of fuel and drinking water for the army. So how to solve this one? Okay, it is example. Huh. University leadership and renewable energy. Smart move and keep the brickness from the Cambridge University. Cambridge University declared that divest from the all direct and indirect investment in the fossil fuel by year 2030. So the 10 years in ahead, there is revolution in energy. So what we must do? We must pick up the future and we become leader in our country. So there is no foreigner or the funding lembaga keuangan apa bilangnya international funding drive our decision about the energy. We must independent from them, from their intervention. We must independent. Create something. Create the renewable energy. Our university and research center can provide this one. Okay. Solution. From my expertise, and the Jenderal Matis said, in my dalam istilah saya, sorry, I combine with bahasa to make my presentation looking fluent and smooth. Jenderal Matis said, we must divorce, fully divorce and independent from the land base. What does this mean? Even when the army deploy in the field, okay, freedom from the land base. So there is no problem with resupply water, resupply fuel. How to fulfill the requirement? So the consequence, we need to dance from the kind of energy source and portable to deploy in the field, free from no fuel shortage forever. It's looking as sound utopist, but is can possible to do that? I think it's possible. The Department of Defense US asks the nuclear company in the US, can and possible the nuclear company to provide the small modular reactor, even nano nuclear reactor for the army. So imagine when I will talk in bahasa to make it comprehensive understanding. Coba bayangkan jika Kostrad pergi ke suatu wilayah operasi, mereka membawa mikronuklir gitu. To support apa? Support everything. Yeah. It's I think very nice. It sounds very nice. But the USS can already done the imagination. They asked the company to provide the nuclear. The right side is the figure about the nuclear reactor design. The fuel is uranium. And the interesting from this design is how to transfer heat from the core to end of the generator. They use the heat pipe. Heat pipe is revolutionary in the heat transfer model. So I think many innovation can be applied for the energy area, for example, in nuclear. Okay, I will talk about the small modular reactor. What is a small modular reactor? Then our figure dalam bayangan apa? Dalam our imagine, when we imagine about nuclear reactor, it's very huge, very risky, and very dangerous, very huge to produce electricity. It's the nightmare imagination about the nuclear. But when you going to France, there is ada pameran mode dan gadis Prancis cantik-cantik. The nuclear 70% electricity generated from nuclear in France. But the Frank is enjoy. The people of Frank is enjoy. But Macron is different, okay? Okay. Gen 4 reactor. Right. Now for 2020 until 2030, the nuclear reactor generation come to Gen 4, generation 4 for nuclear reactor design. And Gen 4 need some requirement: safe, sustainability, economical, proliferation, resistant, and physically secure. This is requirement. It must be fulfilled for the every nuclear producer or every nuclear engineer must provide the requirement. Okay, there are 6 innovation of Gen 4 reactor nuclear. There is sodium fast reactor, there is lead fast reactor, there is gas fast reactor, very high temperature reactor, and supercritical water reactor. And the last is, I gave the red circle, is molten salt reactor. I will discuss the reactor. What the interesting from the molten salt reactor? The main characteristic from the molten salt reactor is contain a hot liquid salt with a nuclear reaction take place. And the salt consists of nuclear fuel and several other compounds that optimize the reaction, the heat transfer, and stability in salt. This means the salt mixture in the both of fuel and the coolant. This allows for high heat protection. Because salt has the high heat capacity, so the reactor can be operated in the atmospheric pressure. When the operation in atmospheric pressure is secure, so there is no dangerous part in here. For example, high pressure, you need the special material for it, special treatment, special material, special maintenance for to profit the system. But the system is simple compared to other reactor. Okay. MSR terminology. There is integral and loop. And okay, MSR can support the renewable energy. For example, the integral type of the reactor, the heat from the core can be used to produce hydrogen to support renewable energy, future clean energy. Second one, in the domain of the chevron, the fuel is high very viscosity value. So this is problem to come out from the air. So when they use the reactor, injecting the hot steam on the earth, so make the viscosity from oil is decreased by heat temperature. So the oil can be come out from the earth. Okay. The second one is looping. Loop type of the MSR terminology is used for the electric productivity, okay, to produce electric, okay. This is detailed design. I take design from Torcon, MSR loop, okay. There is 3 in the right circle, there is 3 looping: primary heat exchanger, secondary heat exchanger, steam generator. There are three heat exchanger. So heat exchanger apply a key rule in the nuclear reactor. So in the part is need innovation to downsizing the size of reactor. Okay, compact heat exchanger. The left picture is the molten salt reactor. The 60 years ago, the 60 years ago, the American already fly telah menerbangkan pesawat terbang dengan mesin reaktor nuklir berbasis molten salt. It's very amazing. It's the achievement in engineering 60 years ago. The life is the reactor that really reactor can be built and running, yang sudah berjalan dan benar-benar dibangun. But the problem is number 2, heat exchanger, because there are three heat exchanger in the system. So we must modify and improve the heat exchanger. So I propose the compact heat exchanger to respond a space saving, lightweight and economical heat exchanger. And the main characteristic of heat surface area density, because the heat transfer is in the forced convection and single phase. So the heat transfer area, the key component or key factor to enhance the heat transfer. Okay, I will review the primary heat exchanger. First is compact heat exchanger, prince circuit heat exchanger, and the second one is review of Oakrit 8 megawatt thermal. The PCSE, prince circuit heat exchanger, is part of the compact heat exchanger. The main characteristic of the prince circuit heat exchanger is supported by two technology: chemical etching to make a microchannel pattern on the plate, and second one is how to compose every plate become one system. We call the principle with this heat exchanger. They are diffusion bonding. This is challenge for us to predict this one. Okay. Okay, this is a cell tube heat exchanger from the Oakrit heat exchanger. The type is the tube, U-bend tube, and inside on the cell, and the length is in this case using feet in the American measurement. And next, I will convert in the meter. And this one is low efficiency. So So why we use the prince circuit heat exchanger? The main advantage and disadvantage from the prince circuit heat exchanger for salt, okay, salt and salt, not general, not salt and salt. High heat is transfer density, 2,500 meter square per meter cubic. High maximum operating temperature, 900 degrees Celsius. High effectiveness in order close to 100%. Small pressure drop, light and compact. But disadvantage is new technology and ongoing development of material. Okay, note for the 2 point, the last 2 point. This is we call this, the call is new technology and ongoing development is for MSR area. This is a mature technology. But in the MSR area is a need research for the material. I'm sorry for the picture. I forget it to write the citation in here. I'm sorry, I forget. It's not my picture. Okay, I said my apology. Okay. Next, result and discussion. Okay, I will check the performance of prince circuit heat exchanger on molten salt reactor from Oakrit. And second one, I change the power for 8 megawatt thermal to 550 megawatt thermal based of material, fuel salt, new material vs Oakrit National Laboratory. We use the molten salt from Oakrit as backmarking, and prince circuit was used tip counterflow, and channel shape is semicircular. This is illustration. Left side is the old type of the heat exchanger. The length of tube is 4.3 meter, and the cell is 2.464 meter. And right side is illustration of the print circuit heat exchanger. Length is decreased extremely. From the cell 2.4 meter become 0.33 meter. So it's a very compact, very small, okay, compared to the old one, okay. So this is a detail calculation for my work, and the fuel sat is flynut, lithium fluoride, beryllium fluoride, thorium fluoride, zirconium, and uranium fluoride. For the coolant is lithium fluoride, beryllium fluoride. Number of channel is close to 50,000 channel for hot cold and cold side, and pressure drop is very low, 0.3, and effectiveness is 0.580, and pumping power is 0.5 kilowatt, almost same between cold and hot side. Material has alloy, and volume of primary heat exchanger is 0.037 meter cubic. Amazing. When the power is changing from the 8 megawatt thermal to 500 megawatt thermal, the dimension is quite small. Length is life ONLS and new material is different, okay, but still quite small and low dimension. But fuel physical properties from fuel sat, coolant sat, and material is affected on the dimension from the heat exchanger. Okay. Okay, I will jumping the figure because it's okay. I jumping.
Pak Bambang,
Okay.
we still have 3 minutes more.
Okay. 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 The challenge is how to produce the print circuit heat exchanger. Previous, I said that using the etching method to make a micro channel pattern, but in this case, I try to make a micro IDM combined with CNC. But to bonding the layer by layer, I still use the diffuse bonding. Okay, reason you can see from this page. Okay. This is illustration how to fabricate the micro channel over the plate. Okay, CNC to make pola XY, and micro multi electroda micro IDM to make to scrape micro channel pattern. Okay. Next, this is diffusion bonding. Okay, plate, hot plate, and cold plate, and intermediate plate combined become one system using the diffusion bonding. The key factor, two key factor to make a bonding: pressure and temperature. And interesting, if when can propose new method for make bonding. Okay, this is my conclusion and recommendation. Small modular reactor has potentially to contribute in defense area, especially on the elite unit where need mobility and in massive operation. Molten salt reactor is best choice due to the simple design and application. Print circuit was reduced the dimension of molten salt reactor compared to the cell to heat exchanger. Department of Defense must be explored, and the domestic potential from research center like Batan and university also not only encourage but give the research funding for studying the small modular reactor both in civil and military application respectively. Potentially to produce domestically the important subsystem in the reactor that is a heat exchanger type print circuit heat exchanger. Okay, thank you, Sensei Bindur, for
Thank
the
you.
opportunity.
Thank you very much, Dr. Eng Bambang Joko Suroto. Let's give a big round of applause for Dr. Eng Bambang Joko Suroto.
Thank you, thank you, thank you, thank you.
Then let me call Bapak Yani, Bapak Kolonel Yanif. Are you here?
Yes.
I'm sorry.